Welcome back, students. Today in this session we are going to start a very important topic as far as the motion in a straight line is concerned. It's kinematic equations. So the whole chapter is going to operate only around this kinematical equations from now on, and these things that you study today will again be utilized in most of the places in the other chapters too. So what exactly is a kinematic equation and what are these equations has to do in this particular chapter? Again, kinetic means it is a part of mechanics that is only going to deal with the kinetic aspect of the body, which means if a body is going to move with some particular velocity, and these equations will tell you where can you find it after a certain time. Likewise, we also have accelerations, we have displacements and other things with us. So there are basically four kinematic equations. The first one is V minus U is equal to AT. I am not going to go in and derive this because these derivations are already available for you in your textbooks. So I will just tell you how to use them to solve different numerical questions. Second one, S is equal to ut plus half into A into t squared. The third one is V squared minus U squared equal to 2AS, and the fourth one is Sn is equal to U plus A by 2 into 2n minus 1 it is. 2n minus 1 it is. So these are the four basic kinematic equations with which we will solve almost all the questions. In this, the first three equations are very important and the fourth equation will be very rarely used, only for one particular case. Okay, so what exactly does this V, U, A and S stands for? V stands for the final velocity, U stands for initial velocity, S stands for displacement, A stands for the acceleration, and T stands for the time. T stands for the time period. So these kinematic equations are the ones which are going to completely describe the motion of the body. But in many textbooks, they have failed to show you the limitations of the kinematic equation, so that most of the students go wrong while doing some technical problems. Now listen, I am going to take this equation, S is equal to ut plus half into AT squared. Everybody knows this, but there is a different way to write this. Listen, x minus x naught is equal to u into t minus t naught plus 1 by 2 into a into t minus t naught the whole squared. So this is the correct way of writing this equation, but most of the students don't realize this and they go wrong while doing some technical problems. So what does this x and x naught stand for? Listen, x stands for the final displacement, and x naught stands for initial displacement. T stands for final time. T naught stands for the initial time. Okay. So what does this mean by the way? You see, these kinematic equations are actually designed in such a way to work only from the beginning. For example, there was a situation. I came across a question where there was a situation where the problem is actually designed this way. See, a body starts from here and it goes to some final position. This is the initial part and this is the final part. And in the question they say that for the first 5 seconds a body covers a displacement of s1, and for the second 5 seconds it covers a distance of s2, and s3 is the third part which is again covered in the third 5 seconds. This was the data given to us. S1 is the distance covered in the first 5 seconds, S2 is the distance covered in the second, S3 in the fifth. But if you try to frame the equation for this, you see S1 is equal to, let's consider that my initial velocity is 0, 1 by 2 into A into T1 squared. Then what others do you know? S2 is equal to 1 by 2 into A into T2 square. This is what they write. But that is wrong. Why? See, this equation is framed in such a way that it will operate only from the beginning. X minus x naught, final displacement minus initial, final time minus initial time, like this. So, here that will not work in between. S2 is the displacement for the second 5 seconds, right? So, these equations doesn't operate for the portion which is at the center. So, you have to write it like this, S1 plus S2 all the way from the beginning times A into T1 plus T2 the whole squared. T1 plus T2 the whole squared. Likewise, S1 plus S2 plus S3, the whole displacement, 1 by 2 into A into T1 plus T2 plus T3 the whole squared. This is the way to frame the equations. This is the way to frame the equation. Clear? So, this is the limitation that your kinematic equation has got. And only if you realize this, it will be easy for you to do some complicated questions. Then, there are actually 3 types of motion that we frequently come across. We will see about that now. First one is free falling body. Free falling body. So, free falling body means when you drop something. So, whenever you see few keywords in your question like free falling body, or if a body is being dropped, then you should understand that it is a free falling body, and immediately you realize that the initial velocity for that body is going to be 0 and the acceleration experienced by that body is going to be g. Okay. So, by using these things into the formula, we can actually extract the unknown. For example, S is equal to ut plus half into A into t squared. The initial velocity is 0. Imagine that you are dropping it from a certain height h. S will take an height h is equal to 1 by 2 into g into t squared. So, if you are asked to calculate the time period, then it will be t is equal to root of 2 into h by g it is. So, this is the time taken by the body to fall from a certain height h. This is one way of doing. Like that, you can take the third equation where v square minus u squared equal to 2 into a into s. For a free falling body, the initial velocity is 0. So, this goes to 0 where v equal to root of 2 into g into h it is. 2 into g into h it is. So, these are the few things you can do using the free falling body. Then a body is thrown vertically upward. Body thrown vertically up. So what happens? You give an initial velocity so that your body will reach a certain height and it falls down. So here your initial velocity is definitely not equal to 0. Then your acceleration should be negative g. You know why? Because when you throw a body vertically up, definitely you are supposed to give some initial velocity and that velocity is pointing up, whereas your acceleration due to gravity is going to point down, both being a vector quantity. So any one of the quantity should take a negative sign. I always choose to go with the g value. Okay, I always choose to go only with g value. In few books, in fact very rarely in few books, they take u to be negative. That is not wrong. Okay, but uniformly in almost all the books that I have come across, they have a practice of taking that g value to be negative. So I also stick to that. So when you throw it up, the body reaches the highest position where at that point your velocity is 0. Okay, at the highest point the body is going to acquire a 0 velocity, and let's say h is the height. H is the height reached by the body. So these are the few quantities that you have to put into the equation when you are going to throw a body vertically up. And now in the same way, when you throw it vertically down, let's see what is going to happen. You are standing on a building, and from a top of a building you actually throw a body vertically down. So in that case your velocity is definitely not equal to 0, initial velocity. Your final velocity is not equal to 0. Your acceleration is to be taken as g, because your velocity is pointing down, your displacement is pointing down, your acceleration is pointing down. So all the quantities are going to take only the positive sign. This is throwing down. So this is another way of assuming things. So these are the 3 frequently used motions. Okay, there are few other motions that could be rarely asked, where you go up in a balloon, and in that case when you drop a stone, what happens? So these are very peculiar problems and some rare problems that we will come across, which I will be particularly doing in the numerical session. Here these things that we have studied today is enough to solve almost every problem in kinematics, because all the problems are definitely going to involve one or the other things that we have studied today. But the thing is, everything will be a real life application. So you should have a bit of imagination to imagine what is really happening with the question, and first and most important thing whenever you start solving a question is to draw a diagram. By drawing a diagram and by labeling it, you almost get an idea, a pictorial idea of how to solve the problem. Once this is set and everything is understood, it will be easy for us to solve, because anyways one way or the other you are going to use one of the 3 equations that I have written. Okay, so I will be showing you how the other problems are going to be solved in the numerical section separately. I strongly recommend you to go and check that video, where I have solved many difficult and important problems using very simple tricks. Okay, so with this note we come to the end of this session. We will again meet in the next session with a different topic. Thank you.